Hello everyone. Welcome to the Syed School. Today, we will learn about the subnetting. Subnets and why subnets. Before we analyze subnetting, we need to know the binary format of an IP address. Let's take a Class C IP address 192.168.1.1. Its binary representation is how we make 192 as 110000000, 128 plus 64. Every 1 in an octet, 8 bits, has a value as shown here. In case of 192, we need first 2 bits 128 and 64. 128 plus 64 is equal to 192, so first 2 bits are on, 1, and remaining are off, 0. Similarly, we need to represent other numbers. Let's take a look at network classes again. Consider class A network 10.0.0.0. Here the network portion is 10 and the host portion is 0.0.0. Default subnet mask is 255.0.0.0 or /8. This network has 16,777,216 hosts. However, these number of hosts are always not practical and network ID should be distinct per LAN, per VLAN and per router link. If I use 5,000 host IDs from the network 10.0.0.0, then 167722216 IDs will go waste. So, we need subnetting here. What is a subnet mask? Subnet mask is a mask for the computer to filter the network ID or the subnet ID. Suppose we use the IP 192.168.1.1 with the default class C subnet mask 255.255.255.0. Computer will filter the network ID using binary Boolean and logic. Computer understands just 0 and 1, off and on. Let's write 192.168.1.1 in binary form. And 255.255.255.0 default class C subnet mask in binary. Let's AND the host ID and the subnet mask. How AND Boolean logic works. If both are 1 then AND is 1. If anyone is 0 then AND is 0. Let's AND them here. So, after AND logic network ID is 192.168.1.0. So, we get network IDs by the AND logic. If the network ID is 192.168.1.0 which in binary form is. Here, we have 8 host bits which means that we can change 0 and 1s to get 256 unique numbers which implies 256 unique IP address of this network ID 192.168.1.0. However, what if I do not want 256 addresses and I just need 16 IP addresses per network? Let's take 4 out of 8 host bits and leave just 4 as host bits. The 4 bits which are out are the subnet bits. It will be 2 power 4 is equal to 16 networks or subnets and 16 hosts IDs per network. From 16 host IDs first ID will be the network or subnet ID and the last ID will be the broadcast ID. So, hosts equals 16 minus 2 is equal to 14 hosts. So, we get 16 subnets of 192.168.1.0 classful network with 14 hosts per network. How will the computer know that we have changed the host bits? Computer will know that we have changed the host bits by the subnet mask. So, we need to make all the bits in the subnet mask as 1 relative to the subnet bits. If we change the 4 host bits now, the max host bit number will be 1111 is equal to 15 in decimal form. After 16 host IDs, the network ID or the subnet ID will change. The new subnet ID will be 192.168.1.16 with 16 IP addresses again like 192.168.1.17.18.19 and so on till 192.168.1.31. Again the network ID will change to 192.168.1.32 with 16 IP addresses and so on till the 16th subnet with subnet ID 192.168.1.240 with 16 host IPs. Let's take an IP address 192.168.1.17 with subnet mask of 255.255.255.240 and them to take out the subnet or network ID. We got the network ID of the host 192.168.1.17 which is 192.168.1.16. Similarly, we will get 14 more subnet IDs at an interval of 16 host IPs. Let's confirm this with a subnet calculator. Let's use a subnet calculator. We use subnet calculator in practical world, however, for the exam, we need to understand the subnet calculations. We see a classful class C network ID here with default subnet mask. We can see that the subnet bits are 0. Max subnet is 1 and max host are 254 which is always 256 minus 2. One for network ID and the other for broadcast ID. Now, let's borrow 4 host bits and get 4 subnet bits. Now, we can see max subnets, max host per subnets which is 14 and again 16 minus 2 as always. One for subnet ID and one for broadcast. We see current subnet ID here with the subnet mask and the current 14 host range 2 in this subnet. We see the binary forms here. Please take a look at the subnet ID and the broadcast ID. The subnet ID will change at an interval of 16 IP addresses and there will be 16 subnets in total. Let's go to the next subnet and analyze its subnet ID, subnet mask, hosts range, broadcast ID. Similarly, we will analyze all the 16 subnets of this classful network. This is the last subnet of 192.168.1.0 classful network. How to know how many host bits to leave? It depends on how many hosts you need per network. The formula is 2 power h minus 2, h is the number of host bits. If we leave 2 host bits then we get 4 minus 2 is equal to 2 hosts per subnet. If 3 bits then 8 minus 2 is equal to 6 hosts per subnet. If 4 bits then 16 minus 2 is equal to 14 hosts per subnet. If 5 bits then 32 minus 2 is equal to 30 hosts per subnet. And so on. The number of subnets will be 2 power s equals number of subnet bits borrowed. Number of host bits differ in every network class. Class A network has huge number of host bits to borrow. We have subnetted Class C network in this video. Class A and B networks can be subnetted in a similar fashion.